Good day. We are carrying on after the first half of this section, which was Lewis structures. We move to the second half, which is organic chemistry. You should have this sheet in front of you, and we're going to go over the front side in this video, and the back side I'll use a PowerPoint so you can fill in the blanks on that page. Historically, organic chemistry referred to the chemistry of living things. It is believed that living things had a vital force within their chemicals, and non-living things like rocks didn't, and that was called inorganic. Well, we have these divisions. We still have organic chemistry and inorganic chemistry, but they have different meanings now. If we look at a human being, and let's say this human being 64 kilograms, and we decided to take that person apart, we would find that there are 45.5 kilograms of oxygen, 12.6 kilograms of carbon, and 7 kilograms of hydrogen. Now, what might surprise you is that the most atoms in you would actually, in fact, be made of hydrogen because it's such a light element. But organic chemistry, our modern definition, is going to be carbon chemistry. So on this page, we have a mini history, and so we have Berzelius. And he categorized things as organic and inorganic. And here's the vitalism, the idea that these organic compounds had a vital force. And this theory was defeated, as you can see, by Wohler when he synthesized urea. Lovely stuff. That'll be stinky. It's got ammonium in there. And he was able to make this in a laboratory rather than a human being. Urea is a material found in urine. Acetic acid's another organic compound, and it was first made in 1845. You might recognize this, sucrose. This is the kind of sugar you buy at the store, and the Canadian chemist was able to make it synthetically in a lab as well. So now, organic chemistry is really carbon chemistry. That is our modern definition. And there are millions and millions of compounds, and most of them are going to be organic and contain carbon. And these numbers may even be out of date because it just keeps moving on. So organic chemistry is very important to us in terms of natural products. But if you look down this list here, things like gasoline, when oil gets refined, yeah, you can make gasoline, and you can make things like plastics from that. You can make wax. And also we have things like solvents, polyesters, kind of a polymer, and flavorings and sort of drugs. So when we look at compounds of carbon, it turns out that living things have a wide variety of carbon compounds within them. So you have carbohydrates, fats, sugars, protein. These things are going to contain carbon, and carbon has special properties that we should have learned about with Lewis structures. One of those is it likes to make 4 bonds. The other thing is it is able to bond to other carbon atoms, and when it does this, it can form chains and rings and spheres, sheets, and even balls and tubes. And my Chem 11 students, sometimes they will make models of these organic compounds and will hang them from the classroom ceiling. And so it gives you an idea of the different kind of angles and shapes you can make. Carbon can also form single, double, and triple covalent bonds. So it has a lot of unique characteristics that we don't find for other elements. So that ends the first part, and next part for the back page will be taken care of with the PowerPoint.